Hey, what's up guys, my name is Cherno and welcome to episode 17 of the Sparky game engine series in which we're making game engine from scratch in C++. So, last time we took a look at basically just making one texture and applying that to our batch render, and it was pretty good. I mean, check this out, we've got like a bunch of sprites here rendering, and they're rendering with our little texture here and everything is awesome. And cool, but what if we want to have sprites which have different textures? So what if we want this sprite over here to be one texture and then this one over here to be another texture? Like for example, if you've just got a 2D kind of top-down map type of game, you know, like Pokemon or something, and you want to have a bunch of tiles here that maybe represent like sand or something and then water or whatever, you want to obviously have different textures for each tile or sprite. So how are we going to do that? Well, luckily, it's not too difficult, and we can basically achieve this by just using arrays of textures. So I do not mean the OpenGL texture array. That is evil, do not use that. Or 3D textures, none of that. This is literally having an array of textures, like a normal array of textures, okay? So let's open up Mischief here and basically draw a few things to explain this further. So basically, what's going to happen is each sprite, okay? Each sprite is clearly a renderable, which is why I'm just going to say each renderable is going to have, and renderable 2D of course for now, is going to have a texture, probably a pointer to a texture. Okay, so it's going to have a texture object. That texture object clearly has an ID, and that's just like TID. That's what we made it. It's the OpenGL texture ID. Every renderable has that. So when it comes time to render it, okay, remember, we don't want to render these individually. If we were rendering these all individually, or if it was a simple renderer, all we would have to do is we would have to basically retrieve a renderable such as a sprite. So for all of our renderables, we would retrieve the sprite, and this is kind of what the simple renderer does, right? We would check what the sprite's text ID is, okay, and by text ID I literally mean texture ID, and we would simply GL bind texture with 2D, GL texture 2D, that, and that would be the end of it. That would be the end of it. We're not doing that though. We can't do that because we're not. This is fine, and then we'd have to send the uniform through, and we have to bind. Obviously, when you do stuff like that, you can only do that if it's basically followed by a draw call of sorts. So maybe like GL draw elements would be an example, right? Since our draw elements happens to be drawing, I don't know, up to, well, 50k sprites at once, we can't bind textures for each of those sprites because it happens in just one of these draw calls, right? There's no way to actually set bind textures in between draw calls. So what we want to do instead is basically send them in as attributes. But then comes the question of, what if I want multiple textures? How do I bind multiple textures? Well, all we have to do is use a little something called GL active texture, okay? So we can use GL active texture with a number such as 0, and it will just go all the way up to 31, I think. It should go higher than that. I think 80 is the standard. As in 80 is what the specification says, to have at least 80. But it'll go up to like 31. Let's just quickly check. So GL texture, GL active textures. That's clearly not it. I think it's just GL texture. Yes, it's just GL texture. So 31. No, that's not what. Can you help me out, please? Yeah, so it looks like it only goes to 31 for some reason. But anyway, GL texture 31. So we set GL active texture with GL texture and then a number. And then we can basically have up to 32 textures bound at once with a varying sampler. Right, so our sampler is basically a texture ID that we give to the shader so it knows what to look up in memory. But what essentially happens is this sampler will basically have an array, right, which will contain, say, the numbers between 0 and 31. The sprite has an ID, such as I want to use texture 17 in this array, and then it will draw it with that texture simply by doing that, and we just bind texture active to each of these active GL active textures thingies. Okay? Cool. So that's our idea. Now, the problem is, well, there are a few problems. One of the problems you probably notice is 31. What if I want 50? What if I want 500 textures? Can I not do that, really? Do I have to split up draw calls? The answer is yes. You do have to split up draw calls. But we can certainly have more than 32 textures in our engine. That's not actually a problem. So that's pretty much it. So what we need what we need our batch renderer to do, okay, is when it takes in a renderable, when we submit a renderable, so this is the submit method inside our batch renderer. When we submit something, it's going to query the renderable for it, or it's going to basically retrieve the renderable's texture ID, okay, which will just be like this, for example. This texture.id thing, right? It'll check to see if that texture ID is basically something that we've already got. So for the first 32 textures, it'll be fine. Yeah, for the first 32 textures, if it notices that we're using a texture ID which isn't in some kind of array that we've already defined, client side, right, CPU side, it'll check to see if it's in this array. If it isn't in the array, if this doesn't exist, it's going to have to basically end the draw call, flush everything, okay, process the texture. It can do the texture anywhere, really, but end the draw call, flush, begin, and then probably process the texture in here. It doesn't really matter when, as long as you do it before the draw call, so before flush. But it'll have to process a texture, it'll have to add it into the array, it'll have to bind it to a target, and do all this crazy stuff. So the best part about this, though, is that we can have more than 31 textures, because what happens when we hit that cap, we just flush whatever we've already got, and then bind a set of, say, another 31 textures, okay? Now, will this result in more than one draw call? Obviously. We will basically end up having more than one draw call, right? We'll have, depending on how many times. So basically, our idea is our draw calls will go up by more than 30. So let's just say for each 32 textures, it's going to go up by 1x. So if we have, say, if we really wanted to write an equation for this, and x is the number of textures, basically that would be our draw call equation kind of right now, right? So every 32 textures, we go up one draw call, except it will be probably like +1, right? And it'll round down to an int or whatever. But that's our idea if you wanted to really express what it is. Now, what if we're not texturing, right? That's the other thing. I've covered if we've got more than the required amount. What if we've got 0? Well, that's pretty easy to do as well. We can make 0 or -1 or whatever, really. It's probably 0 might be a better option because it will deal with unsigned. But we can check to see, if it has no texture or whatever, we really can skip this whole process, yeah? If it has no texture, we can just say if the texture ID is 0, for example, yeah, just don't do this whole checking situation. All you have to do is just continue on, basically, and set the texture ID, obviously, in the thing to 0, and then when it comes to the shader, it will obviously see that, you're using a texture ID of 0, thus I'll draw you a non-textured quad or something like that, okay? So that's the idea. Is it simple? Not really, but it is not that complicated either, and that's pretty much the idea. But of course, it's incredibly powerful, and it will let us have almost as many textures as we want, okay? Basically limited by memory and stuff like that. Okay, fantastic. So let's begin. In our sprite, or the first thing I'll probably do is let's go to renderable, and I'll give every renderable a texture. Okay, just a texture pointer like that. We'll also have we can make this inline const, whatever. An inline const, so we'll have an inline const called something like, I don't know, gluint get TID. Okay, so that'll be our texture ID that we want to retrieve. So what that will do is it actually has to do a few things. It has to basically return, so it might return 0, okay? It will basically check to see if, I definitely should call this mTexture. It'll check to see if mTexture is null pointer. If so, well, we are returning an unsigned at this point, so we'll say something like, let's return 0. Else, we'll return mTexture dot or arrow get ID, okay, which I'll have to add to the texture in a minute. Okay, that's our basic plan. It's pretty simple. So that means that if we do encounter something that is 0, that means that we don't want it to be textured at all. So we are still supporting the fact that, oh, maybe I just want to draw a solid color, not a texture, right? That's we still obviously want to support that. We don't want to have to make a texture that's a solid color, for example, every time. Okay, cool. So now that we've done that, if we go into texture real quick and add all of our cool stuff, such as get ID, which will just return that, we should be ready to party. So in batch renderer, this is where the fun stuff happens. So the other thing that I should mention is that all of the binding of textures, all of that like stuff of which active texture do we want to use, all of that stuff, all of the uniforms, all of the setting, the samplers, that is what the renderer does. Remember, we want to keep the renderer. The renderer is like this weird, sad creature that does all of the work, and we don't care. We're making it slave away for us. And then everything else is so much higher level. Everything more is just so much higher class, right? It basically is like, hey renderer, here's my texture. Do something with it. I want it drawn for this sprite at this location, right? That's kind of how it works. So we don't want to do anything like that. Okay? All this stuff, no, that doesn't exist. We want to make a new sprite. We want to pass in either a texture object or maybe even just a path, and be like, I want this to use this. And then again, all the sprite will do is just set it to the field. The sprite is almost just like a plain old data kind of object that just has a bunch of data grouped together in what we call a sprite or a renderable, right? And then the renderer is what is like, oh, I have to somehow draw this texture. I better figure it out. The great thing about this is that the renderer is actually the thing doing the drawing. The renderer is one of the only things that is actually API specific. If we choose to change this into DirectX, right, the renderer is one of the only things that should actually be affected, okay? All this other stuff we're using now, the only stuff that we really, if we just go and look at renderable, for example, the only thing that we're really doing, which is kind of platform dependent, or like API dependent, I should say, is stuff like GL uint, okay? That is just a data type. We can easily change that or define that somewhere else. And if you just check it yourself, really, all a uint is an unsigned int. That's it, okay? That is all it is. It's typedef right here. So that's kind of all we're doing. And if you look through this, again, it has nothing to do with OpenGL apart from that. Again, the texture does, the actual texture loading does, but apart from that, it's just the batch renderer. This is obviously all API specific, but that's it. So it's a good idea to kind of plan your engines or whatever to be kind of API unspecific, okay? You want it to not really care about what API it uses up until the actual implementation of the renderer, which is this. Okay, so now that we've covered all that, we can probably begin and actually make this work. So when we're submitting all this stuff, we want to be able to retrieve, so const gl uint, I'll call this TID, right, texture ID. What is it, renderable, get TID, okay? So when we get this, we want to basically check out a few things. First of all, this color code that we do, all of this maths that we're doing here, doesn't actually need to exist if we're using a texture. So clearly we don't want to do that. So we want to basically say if texture ID is greater than 0, that means we're valid. That means we're going to do a bunch of texture stuff. Else, well, we'll probably do stuff like this and actually render it a bit differently, okay? But that's kind of the idea for now. And you can see this color will scream at us, we don't care, okay? That's the idea. In fact, we can just probably set color up here or something to be just for now at least, so it doesn't scream at us. Unsigned in C equals like 0 or something. Okay, and then we'll just get rid of this. Okay, so if we're valid, it means that we're actually using what is a valid texture. So what we need to do is find it in our texture slots. So we need to set up some kind of array, as I mentioned, which has all of our texture slots. And this is going to be quite a smart array, because inside this array, we have two things, okay? Generally, when you create arrays, you actually have, believe it or not, per value, you've actually got two sets of data. You've got a key, and then you've got a value. So if I'm like, I want an array of names, and I say, let's just put into names at index 0 the name Cherno, for example, and that's my array of names, we have two pieces of data for this. We've got the name, which is the value, okay, and then we've got the key, which is what we use to refer to that particular value, right? The key in this scenario is going to be our actual sampler ID. The great thing about sampler, the great thing about sampler 2Ds, like IDs, is essentially the fact that they start at 0 and they just go up to like 31 or whatever. They are linear. They have nothing to do with texture IDs. Whereas when we actually load texture IDs and whatnot, you actually want to be able to basically, they're different, right? We might load 5 textures, okay? And then we might use texture number 0, 3, and what am I doing? 0, 3, and like 4 or something, okay? That means it's not the same. So we might want to link sampler ID 0 to texture 0, 1 to 3, and 2 to 4. So basically what I'm saying is the OpenGL texture IDs will have nothing to do with, they're not in really chronological order, okay? But this is always going to be from 0, 1, 2, 3, all the way to 31. That's how it works, okay? It's that simple. So when that happens, we want to set, remember that's the other beautiful thing about it. We want to set whatever we choose here. So basically, sprites themselves don't actually have like what's called a texture ID. They don't have like this sampler ID thing that I'm talking about. They have an actual texture, okay? What sample, let me just quickly include texture as well. The sample slot that it actually refers to is completely set by the actual renderer, okay? It has nothing to do with the renderable, right? It doesn't know what sample. It's like, I want this texture drawn, you figure it out, renderer, okay? And the renderer has to figure it out. So the idea is this renderer, this batch renderer, let me just get rid of almost everything else because I don't like seeing a lot of things around me class-wise. In batch renderer, what we'll do is we'll have a vector of GL uints, okay, which are basically going to be our samplers. So we could probably call this something like M texture slots, okay? What happens is when we look at something, we need to immediately see like if we can find this texture ID in our sampler slots. So back to our awesome diagram, I told you that all of this stuff links. So if we have, let's just say we've got 3 sampler slots, right? We've got 3 entries into our texture slots array. Yeah, here they are, 0, 1, 2. This corresponds to texture ID 0. This corresponds to 3. This corresponds to 4. Okay, so when our sprite comes in for rendering, so this is our sprite, yeah, and it has a texture ID of, I don't know, it wants texture ID 3. This is an OpenGL texture ID, nothing to do with samplers or anything like that. We need to search our array and be like, oh, we want, here it is, we found it, it exists, okay? It does have a sampler applied to it. That sampler is set via a uniform. Everything is great, okay? When that happens, this sampler ID is what we apply to the buffer, our buffers, like texture ID thing. It gets, oh, okay, it's got number 1 applied to it, which means the texture, OpenGL texture ID 3 will be rendered when the sprite gets rendered. Okay, that's how it's going to work. There are a few things we need to talk about, which is, for example, how Okay, well, the next scenario is probably like, what if I want TID 5? Is that in here? No, I need to add it, okay? So I need to say I've got 0, 1, 2, and then suddenly 3, okay? That's a thing now. I need to add that, and it will be 5, okay? Which means that I need to take my list, and I need to push it into the shader again, okay, via a uniform call, which is another kind of scenario that we need to talk about. Okay, cool. All right, cool. So there we go. That's pretty much all I wanted to say, I think. So in this implementation, we're going to say, so let's make a quick search thing that basically looks for it. So found is going to be false. We're going to say for each of our, we want to have I here because we need to know what the texture slot essentially is. So we might make, say, we'll probably have it as a so texture slot TS. We'll probably have it as a float because we'll pass a float into the shader just because it doesn't like it too much. We'll talk about that later as well. But what's it called again? Texture slots dot size I++. And then I think, okay, yeah, so this is, I guess we'll just, yeah, so we need to set, okay. So we'll go ahead and we'll say that if m texture slots I is equivalent to the texture ID that we've requested, which is this one, okay, it means that we found it, so we should set found equal to true. We should break, and we should definitely set our TS equal to, say, float I, right? Okay, so there's the index, because remember the index of this thing is acting like our actual sampler, okay? So if we do find it, okay, this is the second round of things. If we do if we do find it, okay, it's just going to be as simple as we found it. This should probably be outside, by the way. So 0, we probably don't, yeah, okay, we'll do that. So this will remain 0 if that happens, and we'll have to check for that or whatever. But if we do find it, then we simply have to go ahead. Let's quickly jump into our actual buffer, which is our vertex data. We'll jump in there, and we'll go ahead and just add a unsigned int or a GLU int. Again, it doesn't really matter. I'll just keep it as an unsigned int, though, I think. TID. So that means texture ID, okay? And we'll have it right over here. Again, it'll be before color as well. And then in our batch renderer.cpp, we'll just add in, we'll have to have one more attribute, which is TID, which will be index 2, and then we'll move this to index 3, right? So there we go. Those are our things for now. We'll enable TID. So we have to pass this in as an attribute, of course, not a uniform, because it's going to happen like in the middle of draw calls for each vertex. We're not splitting up draw calls here. We can't use uniforms. It's going to be just one. It's going to be a GL float, and it's going to have the offset of TID. Okay, that's it. Looks pretty good. So, and I know I made it an unsigned int, but I'll change that to be a float. Okay, so back out here in our batch renderer. Now that we've done that, again, if this does go smoothly, where are we? If this does go smoothly, then all we really want to do is basically set the texture ID to be our, what is it? Texture slot, right? TS. That's it, okay? And we want to do that for each of our things, okay? Now what we don't want to do is, well, by setting it to 0, we have to then in our shader be like, the texture is 0. That means he doesn't want to use a texture. Let's not use a texture, right? We have to do that. If it's 1, we'll probably use texture slot 0, and so on and so forth, okay? So it'll just be one of those things that we do. Okay, cool. So everything's looking good. So, okay, so if found, again, if it's found, we don't need to do anything because TS is now set to whatever it is, and we can continue on with our lives. Now, if it's not found, this is where the problems begin because we need to update our list of texture slots. So, picture this scenario. This is the first time you've run the renderer. It's got 0 sprites in the texture slot. In fact, texture slots is just empty, so clearly found is going to be false, but we want to use a texture ID. What we need to do is end the current batch of rendering, okay? Because we need to set a uniform. So we might have rendered stuff that did have texture ID of 0. So we might have rendered a bunch of colored tiles before, but now we've actually got textures to render. So we have to end it, okay? We have to flush whatever is left. So in fact, we should flush first and then end probably, since that's usually the way that we work. Oh no, hang on, we have to... What unmaps the buffer? End does. So we do need to end first. But we haven't been doing that. Have we? And that's been... Oh no, the submission. That's right. Sorry, my bad. Because I was going to be really surprised if the renderer somehow managed to work while the buffer was still mapped. But... So we end, we flush, and then we begin again. Now, flush is what should update these texture slots, okay? So we want to basically, again, if the texture slots don't really, like, if the texture slots don't, if they haven't been exceeded, there's really no reason to actually set them up like that, okay? What I mean by that is, let me just think this through. So, yeah. So, to avoid, like, performance considerations as well, the other thing we should do is we shouldn't really do this if we, like... I guess we probably shouldn't do this if we actually, like... If we actually just need to put one more texture in. Because all we should do... That is a flea or something. What we should do... It's still flying around, you thing, go away. What we should just simply do, if we still have space, is just add it into the array. Because remember, all we have is... We probably have a specific amount of texture slots. We want to just simply add the new texture slot in there, so that we now have it. As long as it isn't above, say, 32. And then we don't have to do this. So we need to only do this. Remember, the reason we even do something like that is only if we actually run out of texture slots and we have to resubmit a uniform. That's the only reason we do something like that. So if the size of our texture slots, so what is it, M texture slots, if the size of our texture slots is basically greater than or equal to our max, which is say 32, again, we'll declare that as like a hash define or something, then we do need to do this stuff, and we do need to have flush add all of the good stuff to it. Well, I mean, it'll do it anyway, but we need to actually push back. So I'll explain how this works in a minute. But we need to push back our new texture slot that we've basically decided to do. Which, again, that will just append something, and it'll just be like 31 or something. It doesn't really matter. We just simply append a texture to it, such as... where's our texture ID? Texture ID, right? So we push back the texture ID, and then we set the texture slot to just be the index of m texture slots dot size -1, and we should probably cast that to a float as well. Whoops. Okay, there you go. So that's all we need to do. Okay, and then we have the rest of this event, and as you can see, it's added it and it's appended it, and everything is just the best now. Okay, so the problem begins here. Doesn't really begin here, but now we need to somehow figure out how all of our uniform samplers are actually going to get transmitted into our shaders. So if we just try this right now, what we're going to end up with is a bunch of texture slots which will basically be appropriate to uniforms, but they won't have the proper textures. Might not be bound at this point. That's where it gets that's where it kind of gets a bit tricky. Okay, and we might have to actually well, we will have to bind the appropriate textures, probably in something like flush, I imagine. So when you're about to flush, you need to check to see which ones are in use, bind them to their appropriate targets, and do something like that. So for example, we probably want to do something like, and then to make it even more complicated, it probably has there probably are different shaders per, yeah, that becomes a touch annoying. We need to think up of a way that to make this so that it's not too slow. Okay, so shader side. Let's maybe start with the shader side as well. We've got so let's update these, right? Color is now 3, UV is still 1. We now take in a float called TID, which is our texture ID, and that's at location 2. We pass in a texture ID just like that, and we'll update that to include that. Okay, now our fragment shader is going to take that in, and basically this sampler of text, which we'll call textures, might be like, say, 32, which is, I think, the probably not the max, but it's probably the max that we can have. And then we'll go ahead and just basically say that if so, okay, we do our lighting calculation. Let's get a completely new color, which will be our text color. So we'll look up a texture, okay? So we've got text color, and we'll set it equal to some kind of default. So maybe, so we'll set text color equal to fsin.color. Okay, that's maybe if we don't want a, or in fact, we can probably just, so we've got, right now we've got fsin color. Let's get rid of this. So text color, yeah, so fsin.color, and then if we decide, so if fsin.tid is going to be greater than 0, okay, it means that we've set it to like 1 or whatever, and we want to do this. What we should do is we should basically have color or text color be set to texture. Okay, so textures, and then we need to look up a we need to grab a TID. This needs to be an int though, so I'll just call it TID. We'll set it equal to an int. Best way to do this without ruining everything, because it might get cast downwards and whatnot, is just say fsin.tid plus 0.5. Okay, if we do that, it will just basically, this normal cast will just floor it, and we won't end up with potentially going down to a texture ID below what we have if we lose precision or some ridiculous stuff. So this is just a nice safe way to ensure that we actually get the right integer from our float. We'll look up the texture ID, and then the texture coordinates will just be fsin.uv, which is what we used before anyway. Okay, so there we go. We've set it in the exceptional circumstance that we actually do want a texture. Okay, now out here, all we do is, instead of this, of course, we just use text color. So right now, what it will do is it will basically fall back to the color if we specify no texture. Okay, so it should still work correctly. If we do something like, I don't know, if we decide to let's cover, okay, let's break this down a bit, because this is actually not as simple as I thought it would be. Let's go ahead and just assume that they've all got one shader. So what we'll need to do in that case is, well, it's not that, yeah, just thinking this. Okay, so what we'll do is batch renderer in the flush. We'll go ahead and we'll go through, because remember, the shader doesn't need to get changed. We just need to rebind everything. So for in I equals 0, I is less than m, what is it? M texture slots dot size I++. We'll go ahead and we'll set the active texture. Should be GL texture 0 plus I. Now these are all in a row, by the way. If you look at this, you can see it goes 0, 1, 2, 3, 4, 5, and all the way up to 31, which is DF, right? So they're all in a row, which means that we can just simply use plus I with them. And we can do the same thing. We can do the same thing for our what should I say? For our texture slots. So when we call something like GL bind texture GL, so this is actually this is the real texture that we're binding now. So we need to bind the texture, which is essentially M texture slots I, right? That is the OpenGL texture. The index is the uniform sampler, essentially. So now that we've got all these bound, one thing we need to guarantee is that, and the best thing about this is that when we're going through these, we're going through all the sizes, and so this will become a problem if we actually end up having too many textures. So we'll tackle that problem when it actually comes up. But for now, I think we'll just go into our shaders. So when we create our shaders, that's probably going to be the best place to do that. Yeah, so okay, so we'll go enable. I don't really want to do this here. I won't do this here. We'll have to think of a better place to do this eventually, but let's go ahead. Okay, we need to add, so how do we, I've forgotten how to push textures to our arrays. So what I meant by that was how to push arrays into our shader. So let me just quickly Google that. Actually, I might have it over here. Okay, so actually, hang on. Okay, so now shader. Yeah, so I think we can just use set uniform like 1 IV or something, or FV. So in our shader, we'll probably have to modify that to include it, by the way. So if we go ahead and just say 1 FV, we'll need an array of floats. They'll be, we'll need a count. We'll just use int or size I. I think, so GL size I is just unsigned int, I'm guessing. Oh no, it's just an int. Oh really? So it can be negative. Interesting. Okay, so we'll do that. We'll copy 1F. I might actually pop this in this order. I think it makes more sense that way. So you specify what you want first and then the count. So 1FV, except I think OpenGL takes it in this way. Yes, it does. And if we pull out into here, we'll just switch these along. Okay, great. So now that we've got that, and that error will go away, all we have to do is basically make a bunch of text IDs. In fact, sorry, they do have to be ints. because they're samplers. So, lol. We'll make IV as well. Int value. They have to be unsigned. We won't make them unsigned. So value will be that. This will be I. And then that's pretty much it. So we have to go back here, obviously, and clean this up. All right, cool. All right, it's fantastic. So now what we have to do is when we set up our shader, such as this one, we actually need to do a few things. Really, all we need to do is make a bunch of text IDs. So we could just say int or GL int or whatever. Text IDs equals let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8. You could just do you could just make a for loop do this, obviously. And we have to, once we've enabled it, we need to basically just go shader.set uniform1 IV to the name being textures and the value being text IDs, and then the count being, well, in this case 10, right? And that's it. So now that we've got that, and we can get rid of text now because that's no longer a valid thing. Now that we've got that, everything should be the best. Yeah. Okay, so let's try this out. If we just run this now, we should just get a lot of problems here. In timer. What? Why is it suddenly? Oh, hang on a minute. Why is this suddenly killed itself? Why has this suddenly killed itself? It seems to... What the frick? Let me look at this output a bit better. Maths. No, they're warnings. Batch renderer. Here we go. So, I don't know why timer is particularly affected by... These are all warnings anyway. So all the errors are actually in timer. Why? That seems to be some kind of inclusion problem or something. But that's weird because timer shouldn't be affected by it at all. What the frick has just happened? No, that's not a real error. Let's get rid of that. That's so weird. It's clearly a thing. That's, yeah, I do not know. I must have done something pretty silly though. How to track down this problem? So timer has just like committed suicide apparently. For what seems like no specific reason. Like it's not that actually, it's just the entirety of Windows.h. What? What? What has happened? I must have done something bad. Let's see. What the frick? What did I do? That is so weird. That is so weird. That is so weird. It must not be timer. There must be something else going on. Let me just not include timer, and we'll kind of get rid of it and see where else the problems are, because it's a bit hard to track it down like that. So we'll get rid of that and that. Okay, let's build this now. What? 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 That is so weird. That is so weird. I'm gonna have to take a look at that in a minute. Okay, so if we pass in no textures, we'll figure that out in a minute. Well, I just want to finish this. When we pass in no textures, we should get our original colors, which looks like what we actually get. But if we do pass in a texture, the way we do that first of all is by actually setting up a texture for a renderable. So we don't have that yet. Let's do that though. So in Sprite, I'll probably just make another constructor that takes in, instead of a color, it'll take in just a string. Well, no, I'll make it take in a texture. Otherwise I'll have to load it all the time. So color we'll just set to mathsvec4. So we'll set it to pink, which means that it's obviously not rendering correctly if that's the case. But in Sprite, in our header file, we'll make a texture here, and then we will, yeah, everything else looks pretty good, I think. Wait, what did I do? I added the texture. Well, yeah, so we need to actually set the texture, obviously. So we'll go ahead and set texture to texture. Right. What? Where's the renderable? Where's, okay. Texture, right? That's a thing. And why can't I set it? Oh, I'll probably just set it here. Okay. So what we'll do is we will yep, so we'll, okay, so when we add the so we'll create our texture, which was up here. We don't need to do any of this active texture stuff. We do not need to bind the texture. We create the texture. Here it is. Do we specify a color? Yes, we do. I kind of want to keep that though. If how about I just comment it out? Okay, so we've got our texture now. One thing in batch render actually, which I'm pretty sure I did. Yes, so we need to basically make sure that we're still, so remember texture slot 0 means use 0, which means don't use anything, but texture slot 1 means we actually do want to use something. So when we do this, and when we set up the texture slot here, it should basically be i+1, right? Because we want to, because 0 means that it's all like a disaster and everything. So, actually, to be honest, hang on, texture slot 0. 0 shouldn't be that though. Hang on a minute. Yeah, so we bind that to whatever the first slot is. Texture slots I. So texture slots I will be 0. I don't think we need that. Oh, well, we definitely do, because otherwise it sets it back to 0. But I mean, that needs to be there, but it should be i+1, and that's our texture slot. So texture slot 1 means active texture 0, basically. Does that seem legit? That's totally fine, yeah. Okay, cool. So I was just making sure, because it didn't make sense in my head, but now it does. So, get back in there. So, when we do this now, why you're still sad for some reason. What's the problem? There's a problem, maybe. Let's just read what the problem is. Oh, let's make it on the... So we'll have to delete our textures separately, by the way. Because we might want to have the same texture for multiple sprites. Let's quickly fix this as well. Our timer was quite sad. We'll just move this up to like here. It should be happier. There we go. Okay, so we're running pretty fast. We seem to be getting a black screen, which is not what I had hoped for. Our texture is test. And everything else looks pretty good. So, hang on. Okay, so we're rendering the layer. That's right. Yep, that's totally best. Then over here we're setting texture ID to texture slot. Let's just step through this real quick. So, TID is 1. That's good. There's probably something wrong with that shader, but hang on. Okay, so it didn't find it. The size is not that. So it pushed it back, and it's now 0. Good. Wait. Lols. It's not. It should just be +1, shouldn't it? So it's 1. That's going to set it up as 1. Okay, so if we just quickly launch this and see what the problem is. Okay, so problem. Let's go into our shader real quick and see what's going on there. Shader. Okay, so we're taking the vertex, so we're taking in TID into the vertex shader. Here's our TID. If our TID is greater than 0, texture ID. Oh, that's really okay. Yes. So what is TID, I wonder? So the best way to debug shaders is to not debug shaders. But in all seriousness, the best way to debug shaders is, well, the only way to debug shaders is to make it print colors for you. So let's just see what TID is. Should be all red. It's not. It's erroring me. Okay, they're all red. Good. So that makes it believable. If we divide this by 0.5, it should be... Oh, it's still red. That means that's not good. So what is TID? TID is pretty big then. I'm an idiot, actually. That's also possible. Okay, you are mean. Okay, there we go. So we know that TID is basically 1. We've confirmed that's the case. So we'll go ahead and so what? So TID. So that will set it back to sampler 0. Yes. So that's correct. Now, sorry, it was wrong before. That'll set it back to sampler 0, which will which should work. So now let's uncomment that line, and voila, our texture. So if we go back to main and we try this with more than one texture, it should work up until 32, where problems will begin. So out here we'll... So let's make another texture. test2.png. I'll call this B. So where's our, here it is. So we'll just copy and paste test, because I'm lazy. And we'll call this, we'll open it with paint.net. We'll just make this like a smiley face or something. Maybe in like a nice, this kind of color. That is definitely not a smiley face, lol. There you go. 24-bit. We should probably add support for more than just 24-bit textures. So TB, texture B, TA, texture A. So, I guess we'll just go rand mod 2 equals 0, TA else TB. Okay, cool. So that seems to work pretty well. Let's also try it with 3. I don't really want to try it with 32. That's going to take way too long. I should probably call this T. So at this point, I'll just make an array. So yeah, textures. But no, we need them as. So it'll be an array of texture pointers. So new texture test.png. Okay, and then we'll just go textures rand mod 3. Okay, now we don't have TC yet, so let's save this as TC. And let's change this to something else. Maybe a gradient, how about that? Fancy. Where are my tools? My tools are gone. Maybe I just can't see them. Yeah, they are gone. Okay, gradients. Maybe, yeah, we'll keep this colors, whatever. And then I'll change this to TB. This won't actually do anything. Doesn't matter. We should go through them and delete all of them. Whatever. Yay, 3 different textures. Okay, so this will work for a lot of things. So there's a few things wrong with this. First of all, we're not. We're only initializing up to 9 of these, and you can see in the shader that we've got considerably more. But the other thing is the shader doesn't actually do that. So we probably should have the shader. We should probably have a function in the shader that does this stuff for us. So it like something like initialize text IDs, and it will do like as many as you specify. So you might pass in something like, I want the name textures, and I want 10 of them. And it will just be like, okay, I'll set the uniform textures to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we might do something like that. Also, also I think we're pretty much good apart from that. I mean, if I decide to add something like if rand mod 4 equals 0. I might actually just do this. Else, I'll do that. So now we have our original stuff, which is all blue and stuff now. Wait a minute. Seems a bit wrong. What? Oh no, it's right. It's just, oops. It's just it looked weird without lighting. That's all. So let's add lighting. Where is this? Okay, cool. Cool. So we've got varying shades of red or whatever. We've got textures. We've got a lot of this stuff going on. And of course, our render is still running extremely fast. Let's quickly set up release mode for this because I don't think we've done that yet. No, we haven't. So I think free image and whatnot are just not in there. So out here in directories and whatnot, we'll have to probably add. Oops, the other way around. We want to add that stuff. Yes. We want to add that stuff. And then in input, we want to add all that stuff. I think that's it, right? We didn't add any preprocessor macros or anything. Defines. No. Okay, there's release mode. Let's run it. Good, everything's working. And performance is, as you can see, over 6,000 frames per second, which is very fast for rendering all of this. And you can see the textures are good. So we didn't really test texture overflowing. We'll do that probably sometime in the future because I cannot be bothered testing that many textures right now. In fact, you guys can test it if you like. It's not going to work, I don't think, though. But we'll do that in another episode. This episode's way too long anyway. But anyway, that's the idea. Ooh. A breakpoint, you say? Let's do this quickly. Do it the proper way. Okay, and there you go. All right, cool. Any questions, leave them below, and next time we're going to, I don't know, you know what? Well, I was going to plan out and do fonts next time, but I might do overflowing. Yeah, we'll probably do fonts next time. So if you guys like this episode, please hit the like button, and I'll see you guys next time. Goodbye. Whoa.